Now, we touched on the subject of self-signed certificates before, but I figured it's about time that we went back and looked at it again in a little bit more detail this time round. So what I'm going to do is create, using the self-signed certificate commandlet, a new self-signed certificate, and I'm going to use this now as a root certificate. Now, I don't recommend that you do this for your certificate management, but if you want to use certificates in your lab environment and you don't want to go through the hassle of setting up a full-blown certificate authority, this is probably one of your better options. Now, the reason we're going to create a root certificate rather than creating individual certificates is we want to have a top-level certificate to sign our other certificates that we will use for our web services and other machines in the lab later on. And that way we have a single certificate at a higher level that we can place as a trusted certificate on every machine, and consequently get that trusted certificate for all the lower ones, so that when we create them, they're automatically trusted. So we've done now step one, which was to create the root certificate and trust it. Create the root certificate. We haven't got to the trusting part yet. Now that our root certificate is created, we're just going to quickly check that we have our root certificate thumbprint. Now, the thumbprint is kind of an important one because we'll be using it back and forth from time to time. As an example, we'll be using it to sign the other certificates later, so it's good to know. We're also going to export our certificate to make sure that we've got a backup of it in case we need to refer to it later, which in most cases for our lab environment we will be doing this so that we can export it and then import it to the other machines as and when needed. Since my demo in this case is only using a single machine, we're only going to need to export it for basically example purposes, and then we're going to import it, which would simulate the same step. Now, the important thing to remember when we're doing these exports is it has to be a directory which you can reach, and the other part is that when you're doing the import, it needs to be to the correct folder structure. So certificates, much like registry keys, are broken up into several different areas. Some are related to your account specifically, others are related to service accounts, and then you have the local machine account. So when we're doing the trust in this case, we're going to be predominantly importing into the trusted root certificates of the local machine so that it doesn't need to be done for every user. But let's just use that as the example for now, and we'll move on. So we're going to import the certificate, in this case our backed up one. So we're next going to be asked to put in a certificate path. So this certificate store in this case, as it's referred to. So we put the cert / the local machine. So we're now going under the local machine and we're putting root. So we're putting it into the trusted root. And again, once it's imported, you'll see the same thumbprint that we saw earlier. So we now, in theory, have our trusted root certificate on this machine. So we could, in theory, just use that certificate for everything, but obviously that would be kind of overkill, and it doesn't always match whatever certificate it is that we want to use. So as an example, if we want to set up a web server, we want to have the host DNS name, etc. So what we're going to do right now is create a new certificate for our web server. So in this case, it's going to be named basically our web server .lab.local, and we're going to store it on the same machine, simply because we just have the one for this purpose, although this would potentially be created somewhere else. And what we're going to do is use the sign option. So in this case, the signer is going to be our root certificate. And since our root certificate is trusted, we won't need to trust our individual certificate that we have now. So we're going to go ahead and create that. And since we still have the root certificate as a variable, I'm just going to reuse that, and we don't need to add it individually. Usually you'd need to add the details or point the other certificate, etc., etc. But we don't have that problem. So with our certificate created now, we're going to pop over to our web server. We're going to basically just do a quick add of a HTTP port in order to have the certificate connection, HTTPS to be more important, and we can see that we have a valid certificate that matches our requirements, and we're just going to go ahead and add that. So in theory, we now have a website that we should be able to browse to with a secure certificate. So we'll just change the HTTP to HTTPS, and we should be now presented probably with an error. Now, the reason I've got an error here is because I'm browsing to the local host name, and the certificate quite clearly says web server. So we're not resolving the name to the correct mapping in the certificate. So what we've got to do in this particular instance is either A, have a correct DNS entry, or B, I can go over to my local machine and very quickly set up the host file to connect the local IP. So in this case, I'm going to use the loopback 127.0.01 and point it to web server 1.lab.local in order to be able to resolve the domain name locally. Now, surely enough, once this is entered, all we're going to need to do is go back to the page and do a quick refresh, because all the host entry files are pretty much live the moment you save them. So here we can do a quick ping test and confirm that we're able to resolve it, and we just simply put in the web server.lab.local and we get a response, and we can see the certificate, and it's a valid certificate and a trusted certificate, etc., etc. So all is working as it should be. Now that proves an example of how this can be set up. What I'd like to do now is go through some of the additional options on the self-signed certificates that we didn't get a chance to use. So first one off the bat, let's look at what we have created. So if I go into the MMC, add the plugin for certificates, and then just add the local machine, we should be able to see the certificate we created, and you'll see that the default that is created when we haven't specified any additional options is 1 year. So 1 year from today's date is as long as the certificate will last, and if we look at the certificate information, we'll see it's an RSA key using 248-bit. Now, I'm not a big fan of the 2048, simply that it's really not long enough anymore, and also certificates, frankly, 1 year is kind of a bit limited. So let's address the first one. Let's change the year. So we can use the dash not after. So this tells us the certificate will not be valid after. So we're specifying basically an end date. So in this case, we're going to use the get date, and we're going to use the add year and say 10 years. So in this point, that would be telling it this certificate will not be valid after 10 years from now. So if we do a quick refresh, we'll have created a new certificate, and we'll see that the expiry date is now 10 years from today. Now that hasn't solved the issue with the fact that we're still using an RSA key and it's still using 2048-bit. But hey, let's do that now. So we're going to do this again, and this time we're going to use the key length. And the key length, we can then specify how long we want the key to be. So in this case, I'm going to say, you know what, I want a 4096-bit key, which is frankly these days about the minimum you'd want to use. And if we do a quick look, we can now see we have a 10-year certificate using a 4096-bit key, and that would be a good start. And keep in mind that depending on what program you're using, an RSA key is perfectly valid. As an example, SQL doesn't support any other type of key. So depending on what program you're intending to run, that might not be entirely a bad option. We can also change the key algorithm. So let's say that we're just using this for a website. So we're going to use the elliptic curve algorithm. And if I do a quick look up on the web, I've checked, and SecP384R1 is the most commonly supported, aka all of the major browsers support it. And I'm just going to put a number 2 here in order to differentiate our certificates a little. And what we've now got is an elliptic curve certificate, so it's not an RSA key anymore. And again, we've got a 10-year certificate. So if I just go quickly look at the certificate type, you'll see it's a elliptic curve, and this is a different type. Now there are many more keys than this, but I just want to show you this is how you can change these. Now elliptic curve, the key specification kind of changes the bits, so you don't need to do that individually. Now if you like this video, give us a thumbs up, and as always, subscribe for more content like this one.